Last week, I kind of went over my general workflow with PCG, but I didn't actually go in and show step by step how to make any of the tools. Since then, I have gone ahead and created several levels, including this one here, which is the hub for my game, using the same tools that I have pretty much shown off. This is kind of how everything fits all together. And today, I want to show you guys kind of two things. One, how to create this kind of tile-based floor, as well as the ability to swap the material out, and how to create stairs very easily. Now, there's multiple ways of doing both of these. These are just how I set it up for myself. You can, of course, go in a different direction once you kind of understand how PCG works. It's quite easy to do. So with that in mind, let me show you how it's all done. To get started, of course, as always, make sure PCG is turned on by going to Edit Plugins, searching PCG, and making sure Procedural Content Generation Framework is turned on. Restart your engine as needed. We'll go ahead and get started with the floor. For that, we'll need a few things. So I'm going to right-click, go to PCG, grab ourselves a PCG graph. I'll create an empty graph. That's going to be our PCG underscore floor. I'm also going to need a blueprint class actor, and it's going to be our BP floor. And so I'm going to open up the BP floor, and in here I'm going to add a spline component, and then I'm just going to drag out a simple kind of square here, and then search for close in the detail panel and enable closed loop. And then in my case, because it's all going to be relatively square, I'm going to right click on the points, select spline points, select all of them, and then right click again, spline point type linear. So now we have a square. Before I add the PCG graph though, I am going to go ahead and duplicate the BP floor, and I'll make it a different material. In my case, my default material for the object that I'm going to be using is stone, so I'm going to make this kind of grass. So I'm going to say floor grass. But in the BP floor original, we are going to add the PCG component, and the graph is going to be the graph we created, of course. So now what we can do is drag out the BP floor and kind of make a large area here for it. Something like this should be fine. Now for this floor, I am going to be using cubes basically, but it's going to be using this tiny little cube here. This is the one I'm going to be using. Now, a few slight problems with it. One, it is way too small, and two, I would like the pivot point in the center. So what I'm going to do, because this one is from Megascans, is I'm going to just duplicate the mesh. I'm going to rename this to stone cube, and instead I'm going to use this stone cube one, and then with it selected in the world, I'm going to go to the modeling mode by changing the selection mode to modeling. Then I'm going to go to X form, hit edit pivot, and then I hit center, and then accept. That puts the pivot in the center. And honestly, it is really small. So what I'm going to do is reset the transforms, just put it right at the origin, and I'm going to scale it higher. 10x seems to be like a good size. So I'm going to scale it to at 10x. And then back here in the modeling mode, I can do bake transform and hit accept. And you'll see that the scale is now set to 1. So now this is the default 1.0 scale. And again, compared to the original, that is it there. So this is the one we'll be using. And I have another material that we'll be swapping when we want the variation here. Again, all of this is just the Megascan stuff you can get. So with that, let's go ahead and open up our PCG floor PCG graph. In here, like most, we're going to right click, get spline data to get the information of the spline, then use a spline sampler. And now we need to change the spline sampler from on spline to be on interior. And we need to make sure unbound is turned on because we're not using a volume. And now we need to know the size of that cube. If I go ahead and open our S stone cube, well, I guess it should be SM. That was a typo. I'll rename it to SM stone cube or static mesh stone cube. In the SM stone cube, we can see in the top left corner, the approximate size is 93 by 91 by 92. It's not a perfect cube, but this is just fine. So we can use the average here. We can say 92 is the kind of average we can have here. So in our PCG graph, we're going to set the interior sample spacing to be 92, as well as the border sample spacing to be also 92. At this point already, we can use a transform points node and a static mesh spawner where we plug in our mesh entry of our stone cube. And already we can see there's our stone cube. Honestly, we might want to actually pack this a little bit tighter, but already we're starting to get that base stone look everywhere. So let's go ahead and maybe pack it a little tighter by changing this to maybe 90 and 90. That seems a little bit better. Okay, but it's obviously not interesting. It is all facing the same way, so we need a little bit of variation. In our case, we're using a cube, which means it has 6 sides. When designing something like this, you could design all 6 sides to be unique, but still be the same material, which means you should be able to rotate this in any orientation, obviously in increments of 90 degrees. And so that's what we need to set up. And the way we're going to be doing that is effectively by creating a random number between 0 and 3. So that way there's 4 total numbers, 0, 1, 2, and 3, multiplying that value by 90, and then adjusting the orientations by that. Quite simple. Let me show you how it's done. Before this transfer points, we'll do all of that. So I'll move this up for now. And from the spline sampler, I'll drag out and use an attribute noise. Attribute noise just basically creates a random value from something to something and can output it to an attribute. So for the input source, we need to modify 3 values. So I'm going to change at last to be pretty much any value that has 3. So you can use scale or position, for example. I'll go ahead and use position. The output target is the attribute we want to output it to. Now, we don't want to overwrite position. We just want to output to a new attribute. So I'm going to call this rotation. And then I want to set it between 0 and 3. So if I go ahead and press A on this attribute noise now and scroll to the right, there's our rotation X, Y, and Z. It has randomized, but it is a float value. And we don't really need a float value for this. We want only integers, because if we don't rotate exactly by 90-degree increments, they're going to look really weird. So from here, I can just drag out and search for round. And if I press A on it and we take a look at the rotation X, Y, and Z, you can see there it is, 0 to 3 randomized between all of them. So great. From here, we just go ahead and multiply it by 90, because as I said, we need to have it all randomly rotated in 90-degree increments. Now it's 0 to 270 degrees on all 3 axes. And now we can go ahead and rotate this. Now you cannot use a transform points here. The reason we can't use a transform points is because we have individual information for every single point. If you were to use a transform points, you would need to actually loop on all of these points. We don't need to do that. You could just directly set the rotation based on these values we now have. So from this attribute noise down, I'm going to move this a little lower. And then from the spline sampler, I'm going to drag out and search for set attribute. I'll go ahead and grab it. And now I want to go ahead and set this one up. On this, instead of input source 1, we want to set the point rotation. So $ rotation. And it's going to throw an error because we don't have a second value plugged in that is of a correct type. In fact, if I plug this one in, it's still not going to work because it says rotation from input B is a type vector, cannot be used for operation type quaternion. Rotations under the hood are quaternions. They're not vectors. Effectively, they're X, Y, Z, W, I think. Either way, we just need to convert it basically. So what we can do is after this multiply, we can do a break vector attribute that gets us our X, Y, Z, and W if we have a 4-type vector, which we don't. And then we want to right click and search make rot for make rotation. We want it from Euler angles because we have the angles that we have set. We just want to put them in and you'll see roll, pitch, and yaw. We just plug those all the way through one after the other. And then this can go into the set. And then already we can go ahead and take our transform points and our static mesh spawner and plug it all the way through. And now if we take a look, you could see, well, it no longer looks like it's the same exact one every single time. You could see the patterns are now different. It is now actually rotated each one randomly, so it feels a lot more natural, which is great. But we can go a little bit further now because it is cool, but it is not cool enough. In our transform points now, I want to make a few changes. I want to slightly rotate it, just ever so slightly. I want to go from -2 in X, Y, and Z to +2 in X, Y, and Z, which gives us just a little bit of variation. And I also want to move them a little bit. Before I move them, I want to show that this little bit of angle rotation, right, has given it a little more personality. So it's now much more interesting down here. But if I was to try to offset them, let's say from 0 to 100 in Z, it's not going to actually go always up. Because they're now rotated, it doesn't work that way. But because this is the floor, we can just turn on absolute offset, and then they will go up from 0 to 100. So as you can see, we get something like this. Now, this is not walkable, but if we use the small value, let's say 20, we now get something that is completely walkable, but also interesting in its variation of height. So each one now is randomly offset, and that looks pretty nice. Now, speaking of walking, don't forget that the static mesh spawner by default does not have collisions enabled. So if I open this up and go to the static mesh spawner here, it is set to static, which is great, but the collision by default is no collision. So if you're doing this to actually walk on, and let's say not just for a visual rendering or something like that, you're going to want to change this to something like block all dynamic. And if you have multiple static meshes plugged in there, you're going to need to change it for every single one of them. So don't forget. I forget that myself from time to time. So fantastic. We now have this cool design, and we can go ahead and now draw it out in any way we want and create cool patterns just like that. Slight modification, push it in, pull it out. Nice and easy, but this is a little too slow. So instead, what I'm going to do is I'm actually going to delete this entire floor, and then I'm going to change the selection mode back to modeling, and under this create section, we have a draw spline. I'll go ahead and select it. I'll turn on loop. I'll change the output mode to create a blueprint, and I want it to create the BP floor for me. For the draw mode, instead of tangent drag, I want free draw. I just want to draw it out, and we can just project it right onto the floor here. So if I come here to the top view now, I can just click and hold and just create any design that I'd like, just like this, and when I'm happy, I just let go and then hit accept. And it will go ahead and place that spline in the shape we just drew. And just like that, we have now created the floor in the exact pattern we wanted. And from here, of course, it is just splines. We can go ahead and move these around if I want to control this a little more, if I want this one a little more out, a little more adjusted, or sticking out more, whatever it is, we can go ahead and adjust it any way we wish from here. And the reason this works is because we told it to overwrite the existing spline index. We created a spline and it is overwriting index 0, which is the first one. You can adjust the minimum point spacing to make the points closer or further away, or you can of course choose one of the other options like tangent draw or click auto tangent, whatever you prefer. I really like the free draw to give a really nice random but still hand draw feel to it all. So fantastic. We now have our nice ground in a shape that's pretty cool. Now, what if we want to swap out blocks here? We want to have them a different material, or just what I'm doing in my case, which is spawning to an entirely new piece of geo. So I want to swap them entirely. Well, it's relatively simple to do. For that, we're going to use our BP floor grass spline that we created. I'll go ahead and just drag it out. Now, this seems to be a bug that I have not been able to figure out why with Unreal it does this. When you're working with splines, I just dragged out this piece and you see the pivot point is over here. But in the outliner, I have floor grass selected. But if I control click on floor grass to deselect it and reselect it, the pivot point is now in the right place. Splines are annoying. I will say that. They're very, very good, but this is an annoying thing that once you start editing a spline, it still thinks that whatever you click on isn't still in spline mode, and the whole selection stuff gets That's the best way I can explain it. But just know, if you want to go make sure that you have the object selected, just control deselect it and then reselect it. So all we're going to do now that we have it is just put it up a little bit above the actual floor. The reason I'm putting it above the floor is so I can easily see it later. And now we can go back inside our PCG graph for the floor to modify and use that. To use that spline, we're going to get its information. I'm going to right click and search for get spline data, but instead of using self, the default here, I'm going to do all world actors by class, and I'm going to plug in the BP floor grass here. I'm also going to enable select multiple, and I'm going to turn off track actors only within bounds. So that way it tracks all of them. From here, I'm going to need to do a spline sampler just like the other, and I'll use the same spline sampler. So I'll just duplicate it from above. But here I want to do a slightly different thing, and that is I'm going to use a bounds modifier. Bounds modifier just will scale the points themselves, and I want to scale the bounds min in the z-axis to be 10 times higher. So if I press D and debug this in the world, and by the way, if you do not see it in the world, make sure you have the right one selected in the bottom left, and sometimes pressing A and pressing A to turn it off will help actually display it in the world. And you'll see that there's our points, but they go considerably lower. So this allows you to place the spline above and still have it be intersecting with the original area. Depending on how high up you want to put these for yourself, you might want to scale them higher or lower. For me, 10 seems to do just fine. Now that we have this, we can go ahead and cut them out. So we'll need a difference node. I'll right click, search for difference, and from our original floor points after the spline sampler, I'm going to hook up this difference. So I'm going to hold control from this out and I'll plug this into this out. So I'm going to move all those over, and then the spline sampler is going to go into the source, and then the floor grass is going to go into the differences. And if we take a look now, you can see we have made a hole. Cool. Hole achieved. But here's something interesting. I have this set to minimum. If I have this set to binary, which is what I typically use for a lot of things, I still have a hole. And if I rotate this, I still have, well, an angled hole. But if I was to leave this instead of binary on minimum, as before, I have a hole. But if I rotate this, oh, I have something very different. Minimum works a little bit differently than binary. Binary is definitely, if it overlaps even a little bit, it will remove it. But minimum is a little bit more lenient and gives you this kind of interesting result. So now if I want to create pieces that have random ones removed, I can use an angled version. If I want more or less, I can adjust this. And you can see it's almost in a pattern when it does this. So just keep that in mind. If I was to go ahead and draw out a bigger area here on this angled version, you can see it's almost a pattern. So this might be good, might be not, depending on your aesthetic. But for me, I like this, so I've kept it. And now I can go ahead and put it back if I want to fully remove it or have only part of them removed. By the way, this works with the spline drawing as well. So if I was to delete this, go back to the modeling tools, draw spline, turn on loop again. Loop gets disabled every single time, unfortunately, and plug in our floor grass here and go back to the top view and draw out a new design here. And this is maybe the area that we're going to want as grassy. And again, hit accept. And then we can move this up, and there we go. Now we have these pieces cut out. So that's cool. It's cutting out, but it's not replacing. Well, to place them in in the original locations that the points were that we cut out, we just want to difference the difference, which results in only what's overlapping originally. So if I go ahead and just duplicate this difference node, I can take the original spline sampler, use that as the source, and the output of this difference will be the differences here. And now what I'm going to do is take all of this, because we still want the new ones to rotate the same way. I'm going to duplicate everything here and plug it all the way through in here, just like so. And on this one, I don't have a separate mesh. I just have a material that I'm going to be replacing with it. So I'm going to add an override material, and I'm going to plug that into here. So it's going to spawn this overridden version where the pieces were remaining. And if we take a look, there it is. We have the same mesh now, the same effect of everything, but it is now using this version. Again, I'm doing a demonstration just overriding the material. You can put new meshes here. For example, in my version, right, I have the ones that have grass versus just flat. But just like that, we can go ahead and just draw out whatever we would like and swap them out. And it does completely swap them in the exact same location, as you can see here. Now, this is cool and all, but if I was to take it and rotate it, you'll see that, well, we still have grass everywhere. Well, that's odd. Why do we still have grass everywhere? Here's the thing, though. If I go ahead and just disable the static mesh of the grass, you'll see we actually do have this design and pattern of the holes and everything. But for some reason, this one doesn't work that way. And that's because we're using two minimums here. If we go to this second difference here, the ones for our grass, and we change the density function now to binary, you will see, there we go. Now we're only left with the ones that actually have the holes in it. And if I go ahead and rotate it, right, we get the different patterns and designs now. And once we have zero rotation, we have, well, full replacement. So you can have a little bit of fun having kind of overlapping areas where you have one that kind of does a breakup and maybe another one that you can go ahead and again draw by going to draw spline, turning on loop again, and we can just say, hey, I like this splattering, but I actually want this area right here to be fully grass. And then there you go. That area is grass and the rest is just a splattering. So nice and simple. From here, you can of course create more splines, more variations, set up the differences again to cut things out and replace, just like I did this one, and build on top of that. If you do want me to show more in a future video, please let me know in the comments below, of course. But the next thing I want to show you guys are the stairs. How did I set up the stairs? For the stairs, I'm going to be using these guys right here. This is just castle stairs, again, from Megascans that I grabbed. So what we're going to do is basically place them and then copy them up. So that way they continue building up, 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 and up. A nice, simple version here. For the stairs, of course, we're going to need two things. The PCG graph, an empty graph. You're just going to call it PCG_stairs. And of course, the blueprint actor that's going to hold them, call this BP_stairs. Let's open another BP stairs. And here, all I'm going to add is a PCG component and assign the actual graph. We don't need any other components. We don't need a spline for this. Personally, I like just controlling it from the blueprint in terms of how high and how wide I want it versus drawing it out with a box or something like that. You could, of course, set it up that way. Like I said previously, multiple ways of doing this. I am going to want to control how wide and how high I want it. So I'll add two variables. I'll name the first one width is going to be of a type integer and is going to be exposed. And I'll add one more, and this is going to be our height, integer and exposed. Then I'll compile and I'll set the defaults for both of these on the height and on the width to be 1. And I'll make sure that I cannot enter less than 1 by setting the slider range and value range to be 1 for both of these variables. So that way I can never actually put in lower than 1 because it doesn't make sense to have a stairs negative. But with that created, I can just go ahead and just drag it out and put it in the world for now. And then open up the PCG stairs. We're going to start out by creating the width of them. So how wide do we want the stairs to be? So to do that, we're going to right click, use get actor data. This is going to get the information of the blueprint itself. We're just going to change the mode here to get single point. And then we basically need to duplicate the point sideways. But we only want to do that if the actual width is more than 1, because if it's set to 1, well, we already have that value. That is the default. So we don't need to actually duplicate anything. So I'm going to right click and search for get actor property. And on here, I'm going to type in width for the property name, which is the name of the variable that we have. And I'm going to check if the width is equal to 1. If it is equal to 1, we don't want to be doing any duplication. So we can right click and grab ourselves a branch node. And this equal is going to go to output to B. So when it is equal, it outputs to B. And the output of the get actor data goes into the in. That goes to the branch node. But what happens when it is greater than? It'll output to A. So from here, we can drag out and search for duplicate point. Now this is showing as disabled because I'm currently debugging here in the bottom left. And our stair variable here has it set to 1. So it's automatically showing us us the correct information. You can, of course, change the value here to, let's say, 3. That will make it show up and have the output be grayed out, or you can deselect it in the bottom left. Just keep that in mind that when you go ahead and debug, you'll need to reselect the thing you're debugging. So for the duplicate point, we actually want to subtract 1 because we are duplicating additional. So when we said 2, if we duplicated 2, we'd have 3 total. I would like 2 total. I wanted that number to be exact. So I'm going to take the width, duplicate over here, and then do a subtract. And we're going to subtract 1. And from the duplicate point, I'm going to open it and plug it into iterations. So that's how many times it will duplicate it. But now in the duplicate point, we need to tell it how far to duplicate. So in the point transform here, we can tell it to offset the point relative to the stairs. So if you take a look at the stairs here, on the x-axis, they're 131. So if I offset each one 130 or 131, that should be pretty good. So in the location for x, I'm going to type it 130. So it'll be a tiny overlap. And if you already go ahead and use a static mesh spawner, I can plug in the stairs here and we can already see, hey, there's our stairs. And we can change the value here, 5, there's our 5, and we go to 1, we have nothing. Why do we have nothing? Because we need to plug this in all the way through. Don't forget to not leave any of these empty, or it will, of course, remove those points entirely under that condition. And now it's fine under 1, 2, or any other number. We can have it as wide or as narrow as we'd like. So fantastic. Now we need to, well, duplicate it up. And we're going to do a similar check as we did with the width, but for the height. So I'm going to take this branch and this get actor property equal. I'm going to duplicate it over. I'm going to hold control and move it from the static mesh to be plugged into this in instead. Do a little bit of cleanup and then change this width to instead be height. Again, the other variable that we've created. So only do this if it is greater than 1 in height. If it's not, we can already plug it in to static mesh spawner. But what I'm going to do is just use a simple first transform points node and then plug it in. Because for these, I'm also going to want to use the same kind of random rotation on the transform points by going -2, -2, -2, on XYZ and +2, 2, 2. Again, for a slight variation on the spawning here. Again, creates just a slight bit of randomness here that I personally like with this style. But if we, of course, change the height here to something higher, it will disappear. So let's go ahead and adjust this output A. As you might imagine, we're going to do the same thing here. We're going to take this duplicate points, subtract, and all of this, duplicate it up here. Output A will go into the duplicate point. We'll change the get actor property here to be height. And after this duplicate point, it'll actually go ahead and go back into the same transform points down here. The only difference is we need to change the point transform here. So instead of on X, we want 0 on X. And looking at our stairs, our Y is 113, and that's how deep it goes. And it goes up 64. So if I did 114 and 64 for the Y and the Z respectively, you'll see, well, we almost have this right. The Z is correct, but we need to flip the Y. Because as you could see here in the bottom left corner, the Y positive is actually down, not up. So we'll just change this to -114 and then 64. And we're pretty good, but with the offsets and everything, it seems like we probably could use a little bit less offsets here. So from here, we'll go ahead and just adjust it a little bit, maybe 110 and then 62, a little bit closer, -105, again 62. And that's pretty good. Now here's a tip. You could actually go ahead and randomize the scale to flip it on the width of it. So you have it be one way or the other using the same method that I used for rotating of the blocks for the floor. The only difference is you don't need to do 0 to 3, you just do 0 to 1 and filter out all the zeros and subtract 1, so you just -1 and 1. And then you could just use that for the scale. Same process, with just a slight tweak, you can get a lot of controls from this stuff. But with this in, let's go ahead and add the same kind of railing I had for mine, which is just a block wall here. To do the border, we're going to use the duplicate point again because it's quite simple. Over at the beginning here, we were duplicating to the width and then to the height. We don't need to duplicate to the width, we only want to duplicate to the height. What I'm going to do is take this setup here that's checking the height for the branch. We're going to ignore the ones before it. So I'm going to take all those, take the get actor data, I'm going to duplicate it down below, plug it all the way through. So that again, so it only does things when it is greater than 1. And I'm going to take these duplicate points and again, duplicate them down here. And then from the output A, because we want to do it when it's not equal to 1, go ahead and duplicate the points. If I press D to debug it and change the debug setting here to absolute, you can see there's our 3 points. Okay, fantastic. So now we need to offset them to be half of the width of the stairs here. So we can use a transform points node and then looking at the stairs, which is on the x-axis. Again, our width is 131. So we can offset it on X by, let's say, -70, which is just a little bit more than half. So that would give us a little more room on the side for the actual border. And if I go ahead and use a static mesh spawner, I can put in my kind of border cube, which in my case is going to be the same stone cube that we were using before. And if we take a look, I mean, it's not fantastic. So there's some things things we need to change here. The first thing is I want these all facing towards the next one. I want them angled. To do that, before the transform points, we're going to go ahead and create a spline from these duplicate points. We'll use create spline. On this spline, I'm going to make it linear, which effectively will make the spline just go straight. And then we'll use a spline sampler. And on the spline sampler, we're going to do subdivision, but a subdivision of 0. And then if I go ahead and replug in the transform points, as I had before, you'll see that they're angled the correct way, but they're no longer actually offsetting the correct way. That's because they have now been rotated. And so what we need to do is change these X. It's no longer X, it's Y. We'll do -70 in Y, and you can see that fits a lot bit better. And now we can go ahead and scale this. So I'll turn off uniform scale, and I'll unlock them as well, and I'll scale them to something like 0.3 in Y. I'll do something like 1.2 in X and Z to 1.3 in X and Z. You can actually even give it a variation on the width as well to 0.4. So you just have a little bit of variation here, and you can see, there we go. Now we're starting to get the little border, the same one we had before. We can even go a little bit higher, I think. 1.3 to maybe 1.5. There we go. That's a little nicer. And just like the other ones, I'm going to randomly rotate it between -2 and 2 on all 3 axes. Again, give it a little bit of variation here. And because I think it would look nice, I will also add a little bit extra offset to randomness. So I'll have him go between 0 and 10 up. This is in Z. I'm also going to change this offset on from -70 to -80. Again, more variation here. If I go ahead and change the height here to, let's say, 8, you can see there's our kind of varied stone. And now we just need to copy it over to the other side. But we want to copy it to the other side and not have it be in the exact same location. So to do that, right before this transform points, I will add another transform points. This is going to be doing the offsetting, and that's going to go into this transform points. This is the one that's going to be doing the second side. So we can open it up. We're going to just right click and search for make vector attribute and make sure to change the output type to a vector. So you have a 3 type. We basically now need to offset it by the width times however many there are. So I'll go ahead and grab our width get actor property, and I'll go ahead and multiply it by the width. The width is not necessarily the width of the object. It is what we've duplicated things by. So for example, we've duplicated by 130 here. So I'm going to type in 130, and that is going to be the offset in Y. And then this then goes into offset min and offset max. And you can see here, we now have it on both sides, but it is exactly the same on both sides. We can take a look. This one's a little higher. This one's a little higher. Same thing here, right? It's exactly the same. So what we want to do is take these transform points and check recompute seed, and you'll see it has changed the variation. It might be a little hard to see, so I'm going to toggle it on and off for you. Off, on, off, on. You can see it is randomizing the other side, because effectively what we're doing is the new points, we're re-randomizing the seed, and so it is not using the exact same rotations that we set up here. This -2, these offsets, the scales, all of this is re-affected different. It's perfect. So now we have stairs. And if we go ahead and set the height to 1, we just get the stairs without any of the sides. Now for this style of stair, it might be good to still have them, because this does have no sides. The ones I was using did, which is why I want to show you that you could cut it out. But now looking at this, honestly, we probably want to do it even with no matter which scenario it is. So when it comes to output to B, which is the one when it is exactly 1 distance, we cannot really do duplicating of the points because we don't have multiple levels, and creating a spline doesn't really work either because we have 1 point. We can't really create a spline with a single point. So we need to do this a little bit differently. What we can do is from this output to B, use a attribute filter, and we're going to just say if it is equal to the index, and we're going to use a constant threshold of a value of 0. So we're only going to take the first stair, and then if I plug this into the transform points, you'll see that it actually moves it behind it because it is no longer rotated by the spline. The axes are different. So what we're going to do is take this transform points and take all of this, duplicate it down here, and plug it all the way through. So it's going to have its own custom rotation here, and that then later on goes into the same static mesh spawner. The difference is the transform points, instead of on the Y, if you recall, it's -X, so -70, -80, and the Y gets zeroed out, which means this gets plugged into X and not Y. And when you do that, the inline goes away. So just right click on Y and click activate inline constant. It becomes normal again. So we got now the positions, well, the rotations is off. Now we just grab this transform points because both sides go through it, and basically just do +90 on both the minimum and the maximum. So effectively it's going to go from 88 to 92, and you'll see it is now kind of flat here. You could angle it, of course, from here if you'd like, but I think considering that it is only a single step, I kind of like this. And now all we need to do is just change the amount of them. So if I set it to be 2, for whatever height you want, it will go ahead and spawn them accordingly. And same thing with the width. I can make it 1, 1 or as wide as I'd like. That's how you kind of can create the same kind of style that I'm doing for my environment. And like I said, there's multiple ways of doing all of these things. These are just ways that I found that work pretty well, or at least the way that I like to work. And hopefully what I've shown you here will inspire you to create your own tools and things of that nature that will help you out in your environment journey. And if you want to play around with these for yourself, of course, the project files will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link, as always, is in the description down below. And if you're looking for more awesome PCG tutorials, I want this one right over here, I think you're really gonna like.